Modernage MCQs Physics second year, unit number 17, Electronics, part 5. The depletion region of germanium is 0.3 volts. It does not conduct forward by source of voltage. Option A 0.2 volts, option B 0.4 volts, option C 0.6 volts, option D 0.8 volts. The key is 0.2 volts. Therefore, the correct option is A. Reason: the potential barrier of the germanium diode is 0.3 volts. Therefore, this potential barrier is overcome by forward bias source of voltage greater than 0.3 volts. In common base configuration of an amplifier, the DC alpha factor is the ratio. Option A, delta IE to delta IC, option B IE to IC, option C delta IC to delta IE, option D IC to IE. The key is IC to IE. Therefore, the correct option is D. Reason: the ratio of collector to emitter currents IC to IE supplied by biasing sources is called alpha factor or amplification factor. Hence, in common base configuration of an amplifier, the DC alpha factor is IC to IE. In common base configuration of an amplifier, the alpha dynamic factor is the ratio. Option A, delta IE to delta IC, option B IE to IC, option C delta IC to delta IE, option D IC to IE. The key is delta IC to delta IE. Therefore, the correct option is C. Reason: the ratio of change in collector current to change in emitter current, delta IC to delta IE by a signal, is called dynamic alpha factor or amplification factor. Hence, in common base configuration of amplifier, the dynamic alpha factor is delta IC to delta IE. The DC alpha factor is equal to option A 1, option B 2, option C 3, option D 4. The key is 1. Therefore, the correct option is A. Reason: for a transistor, IB is nearly 0. Therefore, from IE is equal to IC plus IB, we have IE is equal to IC plus 0, or IE is nearly equal to IC, and alpha is nearly equal to IC over IB equal to IC over IC, which is equal to 1. Hence, the DC alpha factor is equal to 1. The beta factor is related to alpha factor as option A, beta is equal to alpha divided by 1 minus alpha. Option B, beta is equal to alpha divided by alpha minus 1. Option C, beta is equal to alpha divided by 1 plus alpha. Option D, beta is equal to alpha divided by alpha plus 1. The key is beta is equal to alpha divided by alpha minus 1. Therefore, the correct option is B. Reason: the equation IE is equal to IC plus IB can be written as IB is equal to IE minus IC, and beta is equal to IC divided by IB can be written as beta is equal to IC divided by IE minus IC. Now dividing the numerator as well as a denominator by IE. We have beta is equal to IC divided by IE divided by 1 minus IC divided by IE, where IC divided by IE is equal to alpha. Therefore, beta is equal to alpha divided by 1 minus alpha. Hence, the beta factor is related to alpha factor as beta is equal to alpha divided by 1 minus alpha. For NPN transistor, alpha is nearly 1. What will be the beta? Option A, infinity. Option B, 10 power 99. Option C, 10 power 9. Option D, 0. The key is infinity. Therefore, correct option is A. Reason. The relation between alpha factor and beta factor is beta is equal to alpha divided by 1 minus alpha, as alpha is nearly 1. Therefore, beta is equal to 1 divided by 1 minus 1, which is equal to 1 divided by 0 is equal to infinity. Hence, beta factor is infinity. Solar cells are used in solar panels to convert. Option A, chemical energy into electrical energy. Option B, light energy into electrical energy. Option C, mechanical energy into electrical energy. Option D, sound energy into electrical energy. The key is light energy into electrical energy. Therefore, the correct option is B. A reason. A solar cell is a p-n junction. When solar light falls on it, the covalent bonds break into free electrons and holes. They rush in opposite direction, electrons towards N region side while holes toward P region side, generating conventional current. Hence, solar cells convert light energy into electrical energy. The alpha factor is related to beta factor as option A, alpha is equal to beta divided by 1 plus beta. Option B, alpha is equal to beta divided by 1 minus beta. Option C, alpha is equal to beta divided by beta minus 1. Option D, alpha is equal to beta divided by beta plus 1. The key is alpha is equal to beta divided by 1 plus beta, which is the correct option is A. Therefore, the reason for the relation beta is equal to alpha divided by 1 minus alpha, we get the alpha factor as the arrangement of beta is equal to alpha divided by 1 minus alpha gives alpha is equal to beta into 1 minus alpha, which is equal to beta minus beta alpha, or alpha plus beta alpha is equal to beta, or alpha is common into 1 plus beta is equal to beta, or alpha is equal to beta divided by 1 plus beta. Hence, the relation is alpha is equal to beta divided by 1 plus beta. For a p-n transistor, beta tends to infinity. What will be the alpha? Option A, infinity. Option B, 10 power 99. Option C, 10 power 9. Option D, 1. The key is 1. Therefore, the correct option is D. Reason. The relation between alpha factor and beta factor is alpha is equal to beta divided by 1 plus beta. For beta tends to infinity, 1 plus beta is nearly beta. Therefore, alpha is equal to beta divided by 1 plus beta is equal to beta divided by beta is equal to 1, because 1 plus beta is equal to beta. Hence, alpha factor is 1. A photodiode in series with a microammeter is used in the circuit of lamp. A student in dark room measures the current. Option A, 2 microampere. Option B, 1 microampere. Option C, 0 microampere. Option D, minus 1 microampere. Option C is the key. Therefore, the correct option is C. Reason. The photodiode does not conduct in the absence of light. Therefore, the current in dark room through the circuit is zero. Hence, the student measures 0 microampere.